This is a demo on how to import JMAG models directly into ePOP. Here I just launched a very latest release of ePOP. Here's the main window, and I also have the console in the background to see some outputs of what's going on. Since we need specifically for the JMAG model to run a Python script to do all the automated stuff that needs to be done, I need to specify where my local Python installation is. We do have separate instructions and automated scripts how to install this on your computer. And just to demo here, we don't have nothing pre-configured in ePOP. There's no pre-populated models or results for this demo. So what we want to do is go into component generation. Here's a bunch of tabs for inverters, motors, transmissions, and full vehicles. Here's some options of doing Excel imports, which you will see in a separate video. There is the tab for JMAG, which we will focus on today. The options we have is to specify where we want the output files to end up, and this is filled in as the default ePOP folder. And the other one we can select is where to find the JMAG model to convert. And if you have more models, it will pick everything in the folder. This is also filled in with the default path, and this is where I put the demo model I will convert. And now I simply push import JMAG motors. We will run a script, does the job for us. And the script will look for a JMAG installation on your computer. So of course that's necessary. That also includes having the proper licenses to run JMAG and to do simulations. For this example, we have loaded a ID3 RX model. So that's a typical traction motor, radial flux. A fairly advanced design with IPM, 3 magnets design and hairpin windings. And what it does is takes this model, it switches a lot of settings and reconfigures a lot of parameters inside a JMAG model in order to being able to run a parameter sweep. The actual switching takes only a few seconds, and then it immediately launched the reference simulations. So in here, this is the JMAG scheduler. We submit all the simulations from JMAG into the scheduler. And this one will run about 30 reference simulations. And from all of those simulations, it will then try to extract a efficiency map and extract all the necessary equivalent circuit models parameters, which will be fed directly into ePOP. All of that data is necessary to be able to match an inverter to the motor later on, and to extract relevant and accurate parameters for the inverter efficiency as well. So in my case, I have a few licenses available. So I can actually go in here and select, I want to do two simulations simultaneously. And I have configured these simulations to run on multiple cores and running, in this case, at least 2 simulations simultaneously, which will significantly speed up the process. Every case here, so that's every line in the simulation, among the total 30 ones I selected to run, takes about 10 to 20 seconds to run. So this is the longest process in the entire conversion. Expect this to take about 10 minutes. And the more jobs or cases we select, the more accuracy we can get in the final results. So now it's almost finished. All the reference simulations are about to be done. The next step JMAG is going to do for us is to summarize all of the simulations and then start generating an efficiency map. And all of this is automated. So what we see here now is extracting all the operating points necessary to run ePOP directly from within JMAG. It's not only efficiency we're talking about, it's the full power map and torque, and all the necessary voltages, current, and power factors for each individual operating point within the entire operational area. That also includes field weakening performance for the motor and all the losses generated for each operating point. I have not provided a single mouse click input so far. Everything that is happening is it's running on its own, completely automatic. Process is done. You can see explicit output of what's going on from the console. We can now return to the ePOP window. Next step, now we're finished with the C data for the motor model, is that we go into inverter matching. I can do refresh manually to see that within the generated motor map folder, we have two machines. One default sample machine, which has to be here when we open ePOP, and the freshly generated motor model from JMAG. The next step is to match this up with existing inverters. And I can also select a folder here for different inverter models. I then select match inverters. It will do a work on trying to match all of the motors with all of the inverters. And the maps that pops up here, we'll see the efficiency for the inverter when it's paired up with the motor. In the top left, in the bottom left, we'll see the efficiency for the motor when it's running together with this inverter. And then to the right, we'll see the combined efficiency of the both. Now, please note that we are seeing results for both the example seed motor and the ID3 motor that we just simulated. ePOP is automatically checking for compatibility with both voltage and current and speeds and frequencies for each inverter. So even though we have a very long list of possible options here, we will only evaluate the ones that are within the limits of both the motor and the inverter. So for instance, if the inverter doesn't have enough current rating, it will not match properly with the motor. Inverter matching completes. And from now on, ePOP have generated a combination of inverters and motors that it can run and study. The next step is to go into run study. Here we can select battery vehicle. We can select decent input and output range of torque, speed, and we can go initialize. We will select a vehicle, the vehicle parameters, drive cycle, and a selection of inverters or matched inverters with motors, and we can go pre-process.